Sometimes the biggest revolutions in tech, they don't come from some massive, complicated invention. Nope, they come from a single, really elegant idea. And today, we're going to dive into a 2014 research paper that did exactly that. It introduced one concept that kind of quietly laid the groundwork for all the AI we're using today. Let's explore how this one idea really did change everything.
Okay, just take a second and look at this sentence. It's long, it's complex, it's packed with all these specific details. This is exactly the kind of text that used to just break machine translation. For years, if you asked an AI to translate something like this into, say, French, and keep all the meaning, that was a huge challenge. But then, something changed. And here it is, the translation. And it's perfect. It captures all the nuance, the specific terms, everything. You've got admitting privilege, status as a healthcare worker. It's all there. Flawless. This wasn't just a good translation. This was a massive breakthrough, and it was generated by the model from that very paper.
So that's the big question for us, right? How did we get from these clumsy, often totally nonsensical machine translations to that? Well, the answer is a great story about finding a major bottleneck and then figuring out a brilliantly simple way to get around it.
So, to really get why this was such a big deal, we first have to understand the problem. What exactly was holding machine translation back for so long?
Well, the early neural networks for translation were built on an architecture that was, clever, but it was seriously flawed. It was a big step up from what came before, for sure, but it had this one big weakness, an Achilles heel, especially when you gave it longer sentences.
And this was the main way of doing things. It's called the encoder-decoder model. Think of it like this. The first part, the encoder, it reads the entire English sentence from beginning to end. Then, and this is the crazy part, it has to compress every single bit of information, every word, all the grammar, the whole meaning, into one single fixed-size chunk of data, a vector. Then the second part, the decoder, has to write the entire French sentence using only that one little compressed memory file.
So yeah, that second step is the killer. You are forcing the model to cram everything into one tiny box. Just imagine trying to summarize a really long, detailed paragraph, but you're only allowed to use a single, short sentence to hold all that information. You're definitely going to lose some details, right? That's the memory bottleneck.
And hey, don't just take my word for it. The researchers themselves called this out directly in their paper. They identified this fixed-length vector as the core issue. They basically said, look, we think this compression step is what's stopping these models from being able to handle long, complex sentences.
And this chart is the proof. It's based on their findings, and it shows the performance of that old model, which they called RNN-NDEC. So look, on short sentences, it does okay, but check out what happens when the sentences get longer. The performance just falls off a cliff. The model was literally forgetting the beginning of a sentence by the time it got to the end. Okay, so this is where the big idea comes in. Instead of trying to force the model to remember everything all at once, the researchers asked a simple question. What if we just let it focus? What if we let it pay attention? And this is the solution they came up with, the attention mechanism. It's brilliant. Instead of that one fixed memory, the model could now, for every single word it was about to write in French, it could look back across the entire English sentence and decide for itself which parts were the most relevant for that exact moment. It's a lot more like how a human translator works, right? You glance back at the original text as you write, focusing on the specific phrase you need right now. This comparison really lays it out. The old way on the left, that was all about cramming everything into a single memory. The new way on the right, it's more like using a flexible spotlight. You can shine that spotlight of attention wherever it needs to be, moment by moment. It's the difference between trying to remember everything perfectly and just knowing where to look for the right information. The idea is simple, but the impact was just enormous. And we can actually see this attention in action. The paper had these great visualizations. So, when the model is about to output the French word zone, you can see its attention is focused most heavily on the English word area. Then, when it's about to write economic, its focus instantly shifts over to economic. It's dynamically figuring out where to look, creating this beautiful, fluid link between the source and the translation.
So the idea sounds amazing in theory. Super intuitive, but did it actually work? Well, let's just say the results speak for themselves.
And here's the proof in the numbers. We're looking at something called a BLEU score. It's just a standard way to measure translation quality. Higher is better. And just look at that difference. The new model, which they called RNN Search, absolutely crushes the old one on sentences of all lengths. And that's not just a little bit better, that is a massive leap forward.
And this brings us right back to where we started, with that super complex sentence. On the left, that's the old model's attempt. It starts out okay, but then it just gets lost and starts making stuff up towards the end. But on the right, the new model with attention just nails it perfectly. This right here is the difference that one idea made.
So yeah, the model was a huge win for translation, but the story doesn't end there, not even close. In fact, that was really just the beginning. Because this concept of letting a network decide where to focus its own attention, it turned out to be one of the single most important breakthroughs in the entire history of modern AI. The attention mechanism led directly to the invention of something called the transformer architecture. And that T in ChatGPT, yep, that stands for transformer. Attention is the fundamental building block for pretty much all modern large language models. This one single elegant idea unlocked the generative AI that is completely reshaping our world as we speak.
And that kind of leaves us with a final thought, doesn't it? It just goes to show that sometimes the most powerful progress doesn't come from making things more complex. It comes from finding a single, simpler, more intuitive way of looking at a problem. So the question is, what's the next attention mechanism out there, just waiting for someone to discover it?